Have you ever pondered about the universe and its lurking dangers that could cause Earth to explode, ending our existence? The cosmos, in all its splendor, is a vast and unpredictable expanse, with mysteries that we have barely begun to fathom. Yet, amidst the beauty and wonder, loom threats of intergalactic proportions. Today, we are about to embark on a journey into the unknown, opening the Pandora's box of intergalactic threats that could trigger the end of our beloved planet. Picture the universe, a cosmic canvas painted with a dizzying array of celestial bodies, each with its unique story. Now imagine that among these celestial bodies, there exist forces so powerful, so cataclysmic, that they could trigger the destruction of Earth. This is not science fiction. It's a reality that we, as inhabitants of this tiny speck in the universe, must confront. Over the next few minutes, we'll be counting down the top 5 most likely intergalactic events that could cause Earth to explode. These are not just random, far-fetched scenarios. They are based on scientific research, observations, and predictions. From cosmic rays to supernovae, these potential threats are as fascinating as they are terrifying, offering a glimpse into the raw, untamed power of the universe. So what makes these events so destructive? How could they lead to the end of Earth? And perhaps most importantly, why are they so likely to occur? These are the questions we'll be exploring, peeling back the layers of the cosmos to uncover the secrets and dangers it holds. Remember, knowledge is power. The more we understand about these potential threats, the better equipped we are to prepare and hopefully prevent such catastrophic events. But don't worry, this isn't intended to scare you, but rather to intrigue, to stir your curiosity about the universe and its infinite possibilities. After all, exploring the cosmos with all its wonders and dangers is part of what makes us human. So let's dive into the cosmos and explore these cataclysmic events, shall we? Starting at number 5, we have cosmic rays, the high-energy particles zooming through space. But where do these cosmic rays originate? The answer is, from everywhere and nowhere in particular. They are remnants of supernova explosions, colliding galaxies, and other high-energy events scattered across the cosmos. These particles, primarily protons and atomic nuclei, travel at almost the speed of light, carrying energy that is millions of times greater than that of particles in a particle accelerator. Now, let's imagine a cosmic ray burst hitting Earth. What could possibly go wrong? Well, quite a lot. Cosmic rays have the potential to wreak havoc on our planet. They can damage the Earth's atmosphere, altering its chemical composition and triggering climate change. On the surface, they can cause widespread electrical and electronic disruptions, affecting everything from our smartphones to power grids. And let's not forget the biological implications. Prolonged exposure to cosmic rays could lead to increased cancer risks. But before you start building your cosmic ray bunker, it's important to remember that the likelihood of such an event is low. Our planet is constantly bombarded by low-energy cosmic rays, but the high-energy particles that could cause significant damage are relatively rare. The Earth's magnetic field also acts as a natural shield, deflecting most cosmic rays. Yet the universe is vast and unpredictable. A nearby supernova explosion or a gamma-ray burst could send a wave of high-energy cosmic rays our way. The impact of such a cosmic ray burst would be like nothing we've ever experienced. It would be a catastrophic event, altering life as we know it. While the odds are low, the consequences of a cosmic ray burst could be catastrophic. So, as we continue our journey through the cosmos, it's worth keeping an eye on these high-energy intruders. After all, knowledge is our best defense against the unpredictable nature of the universe. Moving on to number 4, we have the age-old threat of asteroid impacts. Yes, those mammoth space rocks hurtling through the cosmos have the potential to wreak havoc on our dear Earth. The likelihood of a large asteroid impact might seem remote, but it's far from zero. These celestial bodies, often remnants from the early solar system, wander close to our planet more often than you might think. Consider, for instance, the event that likely led to the extinction of the dinosaurs around 65 million years ago. A massive asteroid, roughly 6 miles wide, slammed into what is now the Yucatan Peninsula in Mexico. The resulting explosion, equivalent to billions of atomic bombs, threw dust and debris into the atmosphere, blocking sunlight and leading to a mass extinction. The chances may seem slim, but as history shows, an asteroid impact is not out of the question. So, while we gaze up at the night sky, it's worth remembering what might be gazing back. At number 3, we have the terrifying gamma-ray bursts. Imagine for a moment a cosmic event so powerful that it can obliterate whole galaxies. That's the kind of power we're talking about when we discuss gamma-ray bursts. These are the brightest and most energetic events in the universe, often associated with supernova or hypernovae, the spectacular deaths of massive stars. When these stars collapse, they release a colossal amount of energy in the form of gamma rays, creating a burst that can last from a few milliseconds to several minutes. Now, why should we be concerned about these gamma ray bursts? Well, if the Earth happened to be in the path of one of these bursts, the high-energy radiation could strip away our planet's atmosphere. This would expose us directly to the harshness of space, leading to a rapid and catastrophic climate change. However, let's not panic just yet. The chance of a gamma-ray burst hitting Earth is extremely low. These events are rare and usually occur in distant galaxies. And even if one did occur in our galaxy, the Milky Way, the odds of it being directed precisely at Earth are astronomically small. But even with these comforting odds, we can't entirely rule out the possibility. The rarity of gamma-ray bursts might comfort us, yet their potential for destruction is immense. Climbing up to number 2, we encounter the peril of solar flares. These are not just random bursts of light from the sun. No, they're so much more. Solar flares are massive eruptions of energy, light, and high-speed particles that our sun throws out into space. Now imagine one of these flares heading straight for Earth. What's going to shield us? Our planet's magnetic field. But here's the kicker. A powerful solar flare can disrupt this magnetic field, causing what scientists call a geomagnetic storm. And this isn't your friendly neighborhood storm. It's an intergalactic tempest that could bring about explosive consequences for our planet. This might sound like a plot from a science fiction movie, but it's grounded in reality. The sun is an active star, and it's known to produce solar flares quite frequently. Most of these are not directed towards Earth, and even if they were, our magnetic field does a pretty good job of protecting us. But if a flare were large enough, strong enough, and unfortunately aimed straight at us, the results could be catastrophic. So how likely is this to happen? Well, it's not a daily occurrence, but it's not impossible either. We know that the sun has cycles of high and low activity, and during periods of high activity, the chances of a powerful flare increase. Solar flares are a more probable threat, reminding us that our own sun can be a potential danger. Finally, the most likely event to cause Earth to explode, a supernova explosion. But what exactly is a supernova? Picture the grand finale of a fireworks display, only a billion times more powerful. A supernova is the spectacular explosion that marks the end of a star's life cycle. When a star has exhausted its nuclear fuel, it collapses under its own gravity and then rebounds in a shockwave that blasts its outer layers into space. This isn't just any ordinary explosion. A supernova is so powerful that it can outshine entire galaxies. The energy it releases is equivalent to the energy the sun will emit over its entire lifetime. And if that's not impressive enough, the explosion also fires off a barrage of high-energy particles and radiation that can travel across galaxies. So, what happens if a star goes supernova near Earth? The effects would be catastrophic. If a supernova explosion occurred within a few dozen light-years of our planet, the intense radiation could strip away the ozone layer, leaving life on Earth exposed to harmful ultraviolet rays from the sun. Any closer, and the high-energy particles and radiation could directly impact our planet, causing widespread destruction. Now I know what you're thinking. How likely is this to happen? Well, the good news is that there are no stars close enough to Earth that are on the verge of going supernova. However, the universe is a vast place and stars are constantly being born and dying. It's not a matter of if a nearby star will go supernova, but when. The likelihood of a supernova explosion is higher than the other threats we've discussed today. Although the chances are still relatively low in our lifetime, the potential danger is real. And that's why it's so important for us to continue studying and understanding these cosmic events. They hold the key to our survival and our future in this vast, unpredictable universe. The likelihood of a supernova explosion is higher than the other threats, making it the most potential danger to our planet. These intergalactic threats, while frightening, help us appreciate the delicate balance that allows life on Earth to exist. From cosmic rays to supernova explosions, understanding these potential threats underscores the importance of our ongoing scientific advancements. The cosmos is a vast, unpredictable expanse, but with knowledge we can hope to mitigate these dangers, ensuring our survival. So, as we continue to explore the cosmos, remember to stay curious, stay vigilant, and most importantly, stay safe. And before you go, don't forget to subscribe, like, comment, and share our video with your fellow science enthusiasts. Until next time, keep wondering, keep exploring,